Hi, my name is Akash and I'm here to demo the real-time rendering uh, project. I selected a paper that is a vector approach for global illumination ray tracing. So the concept of the paper is to to consider light as a combination of three different vectors. So here the vectors are direct light vector, that is the light coming from the light sources, and indirect light vectors, that is the light reflected or refracted or transmitted through the sources. And also the caustic light vector. So this the rendering equation will consist of the sum of these three vectors, which will contribute to the final color of the pixel. Will uh, will cast a ray from every pixel to each on each object, and the closest hit will gather the information of the closest hit on that object, and for that particular fragment you have to calculate the rendering equation, and then we'll add up by using the bounds, like the vectors which will get reflected will also calculate that value, fragment value, pixel value for that, uh, using the rendering equation, the same rendering equation. So the when the ray is hit, we have to decide the direction through which direction in which it will bounce. So we will be using a random distribution like this, which will bounce a ray in all directions, but we'll pick one random ray in that case. So here is the fragment shader for this, and the main part here is the trace function, which will get the ray, and we will calculate the incoming light for that particular ray, and also we'll set the bounce count, like how many times do we want to bounce the ray, and then calculate the particular fragment color. So if the bounce, like if the ray is hit and there is no color, we will stop the ray bounce for the next iteration. So this it can't contribute to the final color. That's why. And this will get the incoming light plus like from the ray color, total ray color, and from the environment. So here is the scene, and I'll show you. So here is the scene, and uh, here are the mesh the for the scene. So if I run this, the shader will run and it will calculate each pixel color, but it will take some time to render a good quality image, as it has so many bounces, and it will iterate for those number of bounces we have set. So currently I have set the bounces as 10, so it will bounce 10 times before getting the final color of the ray. So it takes some time, but it gets better uh, with time.